We're going to talk about another point of concurrency called the orthocenter today. Remember, a point of concurrency is when three or more lines intersect. And there's a couple of different types, and they are found different ways, and they are used for different things. So the ones we've talked about are the circumcenter, the centroid, the incenter, and now we're going to talk about the orthocenter. So the circumcenter, if you want to remember, it's made up of something called perpendicular bisectors, and that's pretty easy to understand how to do that. You bisect the side and draw a perpendicular line. How do you bisect the side off the graph? Just measure it, divide by 2, and then draw that 90-degree perpendicular line. And you do that 3 sides, and they'll intersect. On the graph, it's the same thing. Make sure you're really accurate by using the midpoint formula to find that bisector point, and then finding the slope and then the perpendicular slope to find, and applying that to the midpoint to find the perpendicular line. For the centroid, recall that that is also starting with the midpoint and connecting it to the opposite angles. And so the centroid is made up of something called medians. It's like a bisector to an angle, but they call it a median. And then we talked about how to do that off the graph and on the graph. And then the incenter is done the same way, both on and off the graph. It's just made of angle bisectors. So there's a lot of ways to bisect an angle. I told y'all in class, just measure the angle and divide by 2. Just bisect it. And then put a little dot at the halfway point and draw that line. And you do that 3 times. So now we're going to talk about orthocenter off the graph and on the graph. For orthocenter off the graph, well, first of all, let's talk about what orthocenter is. The orthocenter is the point of concurrency of the altitudes. And if you've ever been on a plane, they say, like, the altitude of our plane is 30,000 feet, blah, 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 blah. That just means how high something is up off the ground. And if you also want to think about it, ortho, like the orthodontist, they straighten your teeth. They make them like 90 degrees with your gums, kind of. That's what ortho means. It's just another word for perpendicular. So to create altitudes, to create these heights on the triangle, you're just going to find the base of the triangle and the tippity top vertex, the tippity top angle, and then draw a line connecting them so that it makes a 90-degree angle with the base. So if it's off the graph, draw a line from the angle that is perpendicular to the side opposite that angle. So let's talk about how to do this. You should have 3 triangles on your little note outlines. Let's start with the acute triangle. And on the acute triangle, if this is my base, this is my tippity top point. So I'm going to draw a line that is perpendicular, meaning it forms 90 degrees with the base. You can use a protractor, you can use a sticky note, or a corner of a piece of paper that's cut at 90 degrees. And so this is the base, this is a 90-degree a segment that is 90 degrees, and it touches the tippity top point. You'll notice it's not necessarily bisecting the side, so it's not necessarily a perpendicular bisector. And it's also not a median, because a median would connect the midpoint to the opposite angle. So I'm going to rotate my triangle so that I have a new base and a new tippity top point. And so I'm going to draw a segment that forms 90 degrees with the base. Again, use like a sticky note or something to help you draw that 90-degree angle. So this is 90 degrees. Imagine my animations were perfect. And then this is my other tippity top point. So let's rotate it again to where I have my base and my third angle. And I'm going to draw a segment that is perpendicular to my base. So they're all going to meet up at the same point. If you're off by like a millimeter, it's okay because you're a human. But this is called the orthocenter. And in an acute triangle, the orthocenter is always going to be inside the triangle. Now, what if we have a right triangle? Well, if this is my base and this is my tippity top point, if I wanted to draw the altitude, the height of this triangle, then the height would be going straight down at 90 degrees. So that's the altitude of this triangle. Let's rotate it. I'm going to make this angle on top, so I'm going to rotate it. And now this is my base, flat on the ground. And then this is my top point, so the altitude, the height of this triangle, draw a segment that is 90 degrees with the base, and I get this as my altitude. Okay, now let's make this my new tippity top point, so let's rotate it. And if this is my top point, this is my base, flat on the ground. So my altitude is this segment right here because that's 90 degrees. And so on a right triangle, the orthocenter is always going to be on the right angle. Okay, now let's do an obtuse triangle. This one's always everybody's scariest one. So if this is the base and this is my tippity top point, I'm not going to go in at an angle. I need to go straight down. So if you need to, you can kind of like put a pencil here to extend the side of your triangle. So here's a pencil extending the side, and then I can draw my altitude straight down. And you've seen obtuse triangles, area equals 1/2 base times height. So hopefully you remember that the height is outside the triangle on an obtuse triangle sometimes. Okay, now let's rotate it. Let's make this angle right here on the top. So now this is my new base. This is my angle. I'm going to draw the height, the altitude. That one's pretty obvious. There's my segment that is perpendicular with the side. And now let's make this one the tippity top point. As you're rotating it, your paper, make sure you don't stop right here, because remember, this isn't the base. This isn't even part of the triangle. We want to rotate it to where this is flat, this side is flat, and then we'll focus on our top angle, our top vertex. So again, it's kind of confusing. If you need to use your pencil to extend the side of the triangle. And now I'm going to draw a segment that is 90 degrees with my base, and that's my segment. And if you look at it, you will have to extend your altitudes and they'll eventually meet up. So on an obtuse triangle, the altitudes all meet up outside. So the orthocenter is outside of the triangle always on an obtuse triangle. And it's always near the obtuse angle. So it's on that side, not on the longer side of the triangle. Okay, so tape that in your notes. And then let's talk about how to find the orthocenter on the graph. If we're on the graph, we have to draw those perpendicular lines. So we're going to apply the perpendicular slope of a side, but to its opposite angle. So let's walk through an example. Here's a triangle, or here's 3 points. Let's make a triangle. So -6, -4, and that's A, -2, -4, that's B, and then 6, 4, that's C. Sorry, my animations are a little sloppy. Use your protractor or a ruler or some sort of straight edge. Make sure that your triangles have straight sides. It'll be a lot better for you, because it'll make it a lot more accurate, and it'll be a lot better for you also because I'm grading, and it better be a really nice looking triangle, or relatively nice, not wibbly wobbly shaky sides. So if I want to find the orthocenter, I need to find the altitudes. So if this is my base right here and I want to find the altitude, remember, I can use my pencil, and then that means this right here is the altitude. But how do we prove it? Well, first you're going to look at the side that you're trying to find the height from, and this side AB. If I want to find that, I need to look at and find the slope of AB. So that is, slope is y2 minus y1 over x2 minus x1. So my two y values from A to B are -4 and -4. So -4 minus -4 over my two x values are -6 and -2. So I did x2, so I did -2 first, minus x1, -6. You can type this in your calculator, or remember, a negative and a negative, minus and a negative make a positive. So -4 plus 4 is 0 over 4, which is going to just be 0. So my slope is 0, which makes sense. That's a 0 slope. And the perpendicular slope is going to be undefined, because that's the opposite reciprocal of 0 over 4 is 4 over 0, and you can't divide by 0. So now I'm going to apply this perpendicular slope, undefines the up and down line, to the angle that is opposite, the vertex that is opposite side AB. So right here, I'm going to apply my slope, my undefined slope. Okay, so that is my altitude, and I kept it going. You'll see why in a moment. Remember, well, actually, I'll tell you right now. Remember the obtuse, on an obtuse angle, remember the orthocenter is on the outside. So that's why I thought of that, and I just kept it going. Okay, now let's pick another side, side AC. If I picked side AC right here, I could rotate my picture, Let's first just prove this mathematically. So I'm going to find the slope from A to C, rise over run, and then simplify it, or y2 minus y1 over x2 minus x1. And when you plug everything in, you should get 2/3. So that is the slope of this line. But we want to draw a perpendicular line, so we need to use the perpendicular slope. Remember, that's the opposite reciprocal, so that's -3/2. And I'm going to apply that to my opposite vertex. So again, if AC is my side, B is the only other letter. So I'm going to apply that -3/2 to B. So that means down 3/2, and then connect the dots. If you were to turn your paper, remember if this was the base, this is the height, it forms a 90-degree angle with the base. So you can always check it that way. For the sake of time, you only need to do, you can do all three of them, but in our notes, we're just going to do 2 of them right now. And again, they'll connect somewhere on the outside. Don't worry about where, because on your worksheet, it will actually be on the graph. Okay, so tape that in, and then let me have you practice this on the worksheet.